Well, hello everyone. It's time now for us to continue our journey down the road of writing formulas for ionic compounds. This video is actually not part 2, but rather a prelude to part 2, because there's something everyone must understand about polyatomic ions before we can continue. Because the next set of formulas you're going to write all have polyatomic ions in them. So you might be wondering, alright, so what is a polyatomic ion? Well, if you break down the name, then the definition of it is actually fairly simple. Poly meaning more than one, atomic referring to atoms, and then ion meaning a charged particle. So in other words, a polyatomic ion is an ion that is made up of more than one atom. Up till now, you've been studying or looking at monoatomic ions, such as the sodium ion with a +1 charge, or the sulfide ion with a -2 charge. These are what we call monoatomic ions because they are charged particles, hence the name ion, but they're each only made of one atom. So what is a polyatomic ion? Well, let me show you by example. Here, ladies and gentlemen, is the formula for the nitrate polyatomic ion. The formula for nitrate is NO3, meaning it's made of one nitrogen atom bonded to 3 oxygen atoms. But look what we have here. We have a -1 charge. That means that this entire object has a charge of -1 on it. If you were to count all of the protons and all of the electrons in this NO3 structure, you would find that there's 1 electron more than the total number of protons. Let me draw what this looks like for you. Perhaps you'll get a better idea. But don't worry, you won't be expected to draw these diagrams. I'm only drawing one now for clarification. So nitrogen is in the center. 1 oxygen is bonded off that way. 1 oxygen is bonded off this way, and another oxygen with a double bond is bonded down somewhere here. Each of these bonds is a covalent bond. This is what we call a double covalent bond, and it's these covalent bonds that hold this polyatomic ion together. So in one way, this looks a lot like a molecule, and I suppose you could call it a molecule. But because it has a -1 charge, we call it something else. We call it a polyatomic ion. Now you might be wondering, where exactly is that -1 charge? I mean, here it's written directly after an oxygen. Does that mean that one of the oxygens has the -1 charge? If so, which one? Or could it be that the nitrogen has the -1 charge? Well, guess what? It's none of the above. When we draw a structure for a polyatomic ion like this, we often will put the entire picture in brackets. And then we'll write the -1 charge outside the bracket. And that is because this -1 charge applies to the entire thing. Okay? So it is not true to say that the oxygens, or any of them, have a -1 charge, but it is true to say that this entire molecule-looking thing has a -1 charge. And because it has a -1 charge, we call it a polyatomic ion. Chemistry students are often given a table of common polyatomic ions to refer to throughout their studies. And here's the one that I'll be giving to you guys to use for the rest of this chapter and for the rest of this year. This is the sort of chart that you're always entitled to look at, much like the periodic table, and I do not expect you to memorize anything that is on this chart, although in time you will come to memorize quite a bit of it. This chart has 2 columns. There's no distinction between the 2 columns. It appears that the polyatomic ions are roughly listed in alphabetical order. And what is given for each polyatomic ion is its formula, as well as its charge and its name. What you'll see if you look through the names of the polyatomic ions is that most of them, but not all, end with the same one of 2 suffixes. Okay, that being ATE. And the other very common one is ITE. Not all of them do, but most of them do. Common exceptions are our friends cyanide here. Yes, that's the poison. Peroxide. Yes, that's the same peroxide that we have in hydrogen peroxide. And hydroxide below it here, which is actually quite common. You're going to see this one a lot, ends with IDE. A good thing to note is that when there is a charge of -1, this table only lists a negative sign. It has the understood invisible number 1. I personally prefer and often will write the 1 to denote a -1 charge. Sorry, right here, not here, right here. But sometimes you won't see it that way. You'll see just a negative sign indicating -1 charge, or even a positive sign indicating a +1 charge. Also, I more frequently will write a charge of -2 just as it is said, as -2. But this table, and what many chemistry sources do, is they write 2 negative, or in the case of phosphate, 3 negative. What does that mean? Well, it doesn't mean anything different than -3 or -2. It's simply a matter of writing style. Okay, a couple things to know on this chart. Let's take a little tour of it. Up at the top here, we have 3 polyatomic ions that have a positive charge, whereas all of the rest have negative charges. That is important and good to know, is that most polyatomic ions have a negative charge and therefore will appear second in their formulas. The first 2 positively charged polyatomic ions do not show up very often in our studies here. Hydronium comes in a lot when you study acids and bases, and dimercury, well, I hardly ever see that one. But ammonium is quite common. This is not to be confused with ammonia. Ammonia is a substance that we can use to clean things. It's a metabolic waste for a lot of organisms, and ammonia's formula is NH3. This is ammonium, whose formula is NH4, and it has a +1 charge. So for all of the positively charged polyatomic ions, this is the one you'll expect to see the most. Now let's take a quick look at our good friend acetate. Acetate appears to have 2 different formulas. In reality, these 2 formulas are the same. They both contain 2 carbons, 3 hydrogens, and 2 oxygens. In the formula on the bottom, the 2 carbons are drawn separately from each other, as well as the 2 oxygens. The formula on the top is the one that is most done in the style that you are familiar with, so I highly recommend you use this formula for acetate instead of this one. This one is not wrong, but this one is written in the style of organic chemistry, and you folks haven't studied organic chemistry yet, probably. So I wouldn't worry about using this one. Most polyatomic ions do have at least 1 subscript, but some do not. Cyanide is simply 1 atom of carbon and 1 atom of nitrogen, and the same goes for the very common hydroxide, 1 atom of oxygen and 1 atom of hydrogen. There's no need for subscripts on any of these. Thiocyanate is in the same situation. There are some, semi-common prefixes that come before some of the polyatomic ions, like per in front of perchlorate, and per in front of permanganate. Those you'll see from time to time. And it's also quite common that 2 polyatomic ions will have very similar formulas, such as nitrite and nitrate, differing simply by the number of oxygens, and their names will also be very similar, differing only by 1 letter in the suffix. Please be careful not to confuse them with each other. It's quite a common mistake. 2 polyatomic ions have 2 names. HCO3 with a -1 charge is called hydrogen carbonate, whereas HSO4 with a -1 charge is called hydrogen sulfate. Be on the lookout for those because you can guarantee they will show up. Also, while we're talking about hydrogen carbonate, you should know that hydrogen carbonate does go by another name, and you should write this down someplace and maybe commit this one to memory, and that is bicarbonate, which I'm writing right now. Well, I messed that up pretty good, didn't I? In any case, bicarbonate is, I would say, a fairly commonplace name to describe this formula. You may have heard of sodium bicarbonate, which is baking soda. If any of you have Arm & Hammer baking soda in your house and you were to look at the label, I would bet that you would see the name sodium bicarbonate instead of hydrogen carbonate. Bicarbonate is simply another name for this polyatomic ion. It can replace hydrogen carbonate, and many chemistry websites and educational sources will use this term bicarbonate, so be on the lookout for that one. Well, that, ladies and gentlemen, is an introduction to polyatomic ions. In the next video, I will show you how to write formulas for compounds that have these polyatomic ions in them. For now, I say to you all, hand, which means have a nice day.